Hi students, Ms. Jarvis here. Today we're going to focus on the distributive property. Now, if you have a question like rewrite using the distributive property, and they ask you to specifically use the GCF, what you're going to start with is you're going to use your 24 and your 36 in your bobsled, and you're going to look for that greatest common factor. Okay, I might be able to take out a 6. 6 goes into 24 4 times, and 6 goes into 36 6 times. Now 4 and 6 also have a common factor, and that's 2. 2 goes into 4 2 times, and 2 goes into 6 3 times. And that's going to be the end of my bobsled. Now that does tell me that my greatest common factor is equal to 12, because 6 times 2 gives me 12. Now, when I use that to rewrite this statement, that 24 plus 36, let's see. I'm going to put my GCF right here on the outside of my parentheses. So that's where my 12 is going to go. Now, when you wonder what's going to go inside here, well, it's helpful if you've used your bobsled, because these two bottom numbers will go inside these spots here, your 2 and your 3. Now, you've now rewritten it using the distributive property. However, I do suggest double checking that. So 2 times 12 gives you 24, and your 12 times 3 is also going to give you 36 with your addition sign in the middle. And that is the same as what you started with. So you know you rewrote it using the distributive property correctly. The next problem that we're going to go over is, does this demonstrate the distributive property? Okay, if you're given a problem like this, the way to check that is to ask yourself, just like we did up here, if I take this 2 and distribute it, 2 times 3 would be my first part of my problem, and then 2 times 5 would be the second part of my problem. Of course, your addition sign is in the middle here. So if I distributed this properly, it should have looked like this. Now, the issue is that this is written incorrectly. There's an addition sign in the middle instead of a multiplication sign. Now, if you weren't sure about that, or you didn't notice that the signs were incorrect, you could always solve it. 3 plus 2 is 5, and 2 plus 5 is 7. Now, 7 plus 5 is 35. Now, if this is 35 and it's really supposed to be the same as this, then we should get the same answer. So let's see what happens when I solve this one. 3 plus 5 is 8. Okay, now 8 times 2 gives me 16, and that is not the same as 35. Okay, so right here I know, no, these are not equivalent. This is not the correct way to show the distributive property. These are not equal statements. Okay? If I were to use the distributive property, it would look like this. Now let's double check this one and make sure it equals 16. 2 times 3 is 6, and 2 times 5 is 10. 6 plus 10, well, that is 16. So this is correct for the distributive property. This one matches this one. This one is not correct. Okay, now, the next thing we'll talk about for the distributive property is how we would rewrite using the distributive property. I often tell my students that if you have a problem like this, you may want to go ahead and draw your parentheses. Okay, you know that multiplication will be in the middle for distributive property, and in this case, addition will be in the middle. Okay, when I distribute, I have 9 times 2 for my first one, and I have 9 times 3 for my second one. And before finishing up, I think I would like to double check and make sure I'm correct. 9 times 2 is 18, and 9 times 3 is 27. So if I have 18 plus 27, I should be able to verify that that is the same solution that I got on the other side. So 18 plus 27, 8 plus 7 is 15. 2 plus 1 is 4. So my answer is 45, and let's just make sure that that's what I get on this side. Okay, now 2 plus 3 gives me 5, and 9 times 5 gives me 45. 45, as you can see, is the same solution. So I know that I did distribute correctly. Okay, now the very last thing that I'm going to talk about with the distributive property is the distributive property area model. Some of us have a little bit of trouble with this, but it does make a lot of sense once you think about it. It shows us why the distributive property works. Okay, now if we have 2 times 3 plus 4, and I draw a picture of that, that's a 2 by 3. Okay, and I'm going to draw a little divider here because it's also a 2 by 4. There we go. Okay, so you can see how this is a 2 by 3 plus 4. Now, when I actually distribute and I say that it's really a 2 by 3 plus a 2 by 4, I think it's helpful to see that this really is the same as my 2 by 3 plus my 2 by 4. You can see that if I push these together, it's the same as what I have here. So the total number of blocks is really a 2 by 7. So I know total I'm going to have 14 blocks in each. So let's just make sure that that is true. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 in this one. And here we have our 6, and we have our 1, 2, 3, 4, 5, 6, 7, and our 8. And when you put those together, you also have your 14. They are equivalent. So that's how our area model makes sense. Now, I know some of this can be complicated. That's why I recommend you maybe watching this video a couple of times and pausing when you need to. And just make sure that you ask your teacher if you have any questions. Thanks for watching.